Okay, welcome back to math class. Yesterday we talked about quadratic functions, and before that we talked about what linear functions were. So today we're going to talk about cubic functions. Now a cubic function is something that's written in this form: ax to the third plus bx squared plus c, hold on, that's hard to read, plus cx plus d. Now what I want you to notice about this is that its first term is ax cubed. That's why we call it a cubic function. Now up until this point we've had linear functions. Remember, those were this equation, y equals mx plus b. The greatest term in these, this is y equals, was mx, right? X to the first. So with linear, we have x to the first as our highest power. With a quadratic, if you guys remember, quadratics, they look like this: y equals ax squared plus bx plus c. The highest in a quadratic is an x squared, and in a cubic function, we get x to the third. So each time we're adding, we had x to the first, then we had x to the second, then x to the third. Now with a linear function, you remember it just looked like, when we graph it, we just get a line. With a quadratic function, when we graphed it, we got a parabola. Cubic functions are going to look more like this. They start off coming from one direction, and they switch to the other direction. What we're going to do with this now is we're going to practice graphing a cubic function together. And the way that we're going to do that is using a table. Okay, so first step to making a table, just like we always do, is we're going to give ourselves a slot for our x's, a place for our equation. Our equation is going to be x to the third plus 4. Oh, hold on. Y equals x to the third plus 4. So we have our x's, our equation, our y's, and our point, our x comma y, that we're going to graph. Okay, now you guys are familiar with how this works. We're going to plug in some x's, figure out what our y's will be, and then plot the points that we get on a quadratic, or on a coordinate plane. Okay, so the points, the x's that I'm going to use are -2, -1, 0, 1, and 2. Okay, so let's start with -2. When I plug that in, I'm going to get y equals -2 to the third plus 4. Now -2 to the third is going to be -2 times -2 times -2. -2 times -2 is 4. 4 times -2 is -8. So we're going to get y equals -8 plus 4. Now -8 plus 4 is going to give us -4. So our x comma y for this one is -2 comma -4. All right, let's do -1. When I plug -1 in, I'm going to get y equals -1 cubed plus 4. Now -1 times -1 is +1, and then +1 times -1 is just -1. So -1 cubed is -1. -1 plus 4 is going to give me 3. So when my x is -1, my y is 3. All right, then we're going to plug in 0. We're going to get y equals 0 cubed plus 4. Now 0 cubed is just 0, so my y equals 0 plus 4, or 4. So when x is 0, y is 4. We're going to plug in our 1. Y equals 1 cubed plus 4. Now 1 times 1 times 1 is just 1, so we're going to get 1 plus 4, and 1 plus 4 is 5. So we're going to get when x is 1, our y is 5. One more, let's do 2. Y equals 2 cubed plus 4. Now 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. So we're going to get 8 plus 4, and 8 plus 4 is 12. So when x is 2, y is 12. All right, so now that we have our 5 points, we're going to plot it on a coordinate plane. Now remember, what we're looking for here is a graph that looks pretty funny this time. Instead of being a line, like a linear equation, and it's not going to look like a parabola, because that's quadratic equations. What I'm looking for is something that looks like this. And that's how I'm going to know that I did it right. Okay, so let's make ourselves a coordinate plane and see what we got. I'm going to make the top pretty big because I know that I have to go all the way to 12 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's see. The furthest back we go is -2, +2, and the most negative we get is -4. Okay, so when x is -2, y is -4. So we're going to go back to -2 and we're going to count down to -4. When x is -1, our y is 3. Not when it's at 0, when it's at -1, our y is 3. When our x is 0, our y is 4. When our x is 1, our y is 5. And when our x is 2, our y is all the way up here at 12. Okay, so do you kind of see how our points get close together and then spread way far out? That's how we're going to draw it. Like it's coming down like this. It's going to hit here, hit here, hit here, and then go up forever. You see how it makes that kind of snaky looking? It's not a line. It's a nice little curve. We get a curve this way, then right here it changes directions and curves the other way. And that's how all of these cubic functions should look when you finish them.